Hello, my name is Aitor, and today I'll be presenting my project completed work for EEL 2061 Programming with C. Um, the breakdown of this project is that there are 6 parts to it, 5 user-defined functions, and a main function that ties them all together. So just based on the instructions of the assignment, we have A through D of the different matrices, equations we're going to have to be doing, so adding, subtraction, multiplication, transposing, and finding the solution of simultaneous linear equations. The reason why there's 5 defined functions is because this fourth one requires us to find a determinant, and so I decided to make a separate user-defined function just to find that. Just a little math. Matrices, to add or subtract the matrices, they must have the same number of rows and columns, so that will be relevant in just a little bit. So yeah, include studio always. I decided to name my my user defined function as AS, just addition and subtraction. Here I am saying, integers of rows A, column A, rows B, column B are integers. Here I'm also just setting the things that we will use for the loops as integers as well, so I and J. And yeah, so here it's just what you can see in the picture. So how many rows, scan, and then you tell them how many columns, scan, and then you tell them so on and so forth. However, as I mentioned before, if the rows of A and B and the columns of A or B are not equal to each other, we'll have to say that. So invalid inputs, please try again. Yeah, so, but let's say it all worked out. So now we have our matrices. So here I am setting those things based on these. So rows A are going to here, columns A are going to B, and same with B. And here I'm also saying that matrix C, which is what our 2 matrices added, is going to be equal to. So I'm just saying that right now it's an integer. So here I'm saying just this right here. So type row, based on how many you inputted here. So I just used 2. So it'll only go for column 1, uh, row 1, row 1, column 2, and then it'll go to row 2. Yeah. And it'll do that for matrix A right here. And it'll do that for matrix B right here. And yeah, and here I'm basically just saying print matrix A here for however many rows. Once again, we just decided, I decided on 2. And then we're going to print that little bar right there just based on the assignment, and then another bar over here, and then the middle, obviously, we're going to be printing for however many columns we decided to. So here's the rows, here's the columns, and then the same thing with B. Yeah, so here we're setting C just as an initial condition to 0, so it doesn't start as anything weird, and because we haven't technically found it yet. Yeah, so here we're gonna do print. Would you like to add? So type A if you would like to add, and subtract. Type S if you like to matrix B from A. And then here you can see I typed A, and that scanned it. So this is gonna be an addition. So if it's not equal to A and it's not equal to S, we're gonna cancel that right away and just say invalid option, and this is gonna keep happening until you do A or S. But if it is A, then obviously it'll do the addition. So here we have matrix C is equal to matrix A plus matrix B, and if you typed S for how many rows and columns, once again you're gonna have C is equal to A minus B. And the resulting matrix is C. So here we have that. And then obviously we have, once again, the bars and whatever you did for the numbers and columns, which will change depending on the size of it. Multiplication next. So once again, just so math, they must equal the rows and columns must be equal from matrix A to B. Here's our completed script. So I'm kind of going to go over this, kind of already went over it in the last part. Once again, rows and columns. Here we have the condition that's specifically multiplication. So if the columns are not equal to the rows, please try again. There's a dimensional problem. But pretty much everything's the same. Matrix A, matrix B, matrix C. Please type. Once again, it's more of the same. And then however many you set here is however it'll equal to. I guess this is the only difference is that now we're finding C through multiplication as opposed to the addition and subtraction, but it's pretty much the same process. We have the bar over here, and then however many you set it to, columns and rows, is however many you'll have. Transposition. So this is basically just saying, we're changing the columns into the rows and the rows into the columns. So ABC, ABC, DEF, DEF. So yeah. I decided to name that user defined function as tran just for transpose. So here we have integer rows A and columns A and then I and J. Here we don't have to do B quite yet because we're going to be changing A into B. But yeah, we're going to be saying once again, print how many, type how many. This is more of the same. And here, right here, you can see that we are starting to set up B, which is what we'll transpose into. So yeah, here's the transpose of the matrix, and basically just J is I is J, and then matrix B, which is what we defined over here, and then same thing over here. So yeah. Finding solutions to simultaneous linear equations. This one did take a little bit more work. Here's the determinant user function that I said, and here's Cramer's rule. We need to find out the determinant if it has any unique solutions, and then first of all, it has to not equal 0, and then we can start doing Cramer's rule as we're creating 3 new versions of the original matrix by replacing the respective rows. So yeah, this user-defined function was in order to use the determinant, and we'll use Cramer's rule. So here I'm setting determinant as a float by 3 by 3, starts at 0. Here I have integer minor matrix 2 by 2, x ji, and here are the different because it's yeah. And so yeah, we'll find the determinant. This is just the equation for it, which took a while, but it should return us with the determinant if everything happened correctly. Yeah. Now we get to the fun stuff, which is Cramer. So obviously another user-defined function, Cramer. So I have my integers I, J, matrix A, matrix B, matrix X, Y, and Z, which is the new matrices, the original, and B. And I have my float numbers X, Y, and Z, which we'll use later. So yeah, just more of the same. Please type row, scanf, same with B, but this time matrix B is only a 3 by 1 instead of the usual like whatever you set it to. So it's a little smaller than A. And yeah, so here we have basically saying the same thing. X is equal to I. They're basically the same, but we're replacing that first column like we saw over here. So we're replacing it with a B. So you're replacing X, the IO with X. And then that's one matrix we've created. And then we created a second new matrix, which is now being replaced with 1. And then 2, which is just saying first column, second column, third column are being replaced with this. And then with our determinant, which we found thanks to our other user-defined function, we're saying the determinant matrix divided by the determinant of matrix A is equal to X. And then same thing. We're just doing this equation right here. Yeah. And so then answers are, here are those float values that I said about before. You're just basically just to type them out here and here. Just make it clean, bars, yeah. Now all of that actually has to go somewhere, so we're not just doing that by themselves or whatever. So here we have our main function, which is just pretty simple. You have choice 1 and choice 2. Print F, which would you like to see? Here you can see that, and then we have A, B, C, and D. A, B, C, and D. What's your selection? And we're scanning for, once again, A, B, C, and D. If the choice does not equal A, B, C, or D, then you have to retype it again. And then, it'll do what's your selection. And then basically while you don't type something right, it'll just keep asking you. But if it does equal A, then we'll go to function AS, as I mentioned before. If you go to B, we'll go to mul, which is multiplication. C, it'll go to tran, and then D, it'll go to Cramer. And if you would like to do another operation after you're finished with, maybe you did over here your function, you like to do another one, you say yes, and then you type anything for no. So here I finished a function, I want to do another one. So I did another one, but I messed up the inputs. So I did another one, and then I can also just, do another one after this. So yeah, that's my main function. So thank you so much for taking the time to listen to me today. Yeah, here are my references. Thank you.